to be talking about some basic data and computational journalism techniques to track disinformation trends on social media. So I'm going to show two main ways of approaching Twitter and Facebook data and some possible analysis that you can do. I'm not going to use the full 2 hours, so I'm going to share a couple of links to GitHubs so you can use the remaining time to play around with the codes that I will share with you. So we are entering in the post-API area. What I meant by this is that platforms have altered public access to their API, and in some cases they have closed it completely, complicating the efforts to research and investigate suspicious content in a comprehensive way, and opening up further questions about the transparency of these platforms when it comes to sharing data with researchers. So the tools that we have at our disposal are limited, especially based on the amount and the sample of data that they capture. And also not all platforms make public the access to their data. But still what we have could be enough to make meaningful analysis. So the Facebook tool Crowdtangle is one of these tools, which gives access to basically all Facebook, Instagram, Reddit public data, and specifically you can access historical data, as we will see. But still is very important to warn that the data is not comprehensive. We can access only public posts on Facebook, for example, within Facebook pages and Facebook groups. And we can only access the groups and pages that are part of the Crowdtangle database, which for some countries like the US or the UK is quite extensive, but it is very, very limited for other parts of the world. Like in some African countries, the database is very limited, which of course raises a lot of questions about disparities in the data access. Twitter is one of the few platforms to provide a relatively public API, but it allows you to browse data that is only a week old from the moment you scrape it. So it's very useful in the case where, for example, an hashtag emerges that attracts a lot of traffic and you want to analyze it. But for, let's say, long-term analysis, it's very limited what you can do. But before we dive into the more practical bit, there's something very important for us at First Draft, which are the tipping points, which are basically indispensable to know if a given content, like a suspicious content, has reached a given threshold that tells us if we should make it public and therefore write an article about it, report on it, research on it or not. Because when journalists discover a piece of content of misinformation, they immediately want to write about it and make it public. But however, this content often remains within closed communities, and by reporting on it, we amplify the content that would have otherwise remained within the small communities. So giving the ability to decompress a lot of this data and see how much traction the posts and the tweets get, it's really important to measure the tipping point. And at First Draft, we generally use 5 different metrics to measure whether a piece of content has reached the tipping point. So the first one is how much engagement has the post or the content received. And also, was it just liked or also shares? It becomes problematic when a piece of content starts to be shared, because this means, of course, an active dissemination and proliferation. Then is the discussion limited to one online community? If it starts in conspiracy communities, for example, anti-vax communities, we're not so interested in reporting on it, because again, we don't want to amplify it. Then as the content jumped between platforms, if it's only on 4chan or 8chan, then it's probably interesting and we should be monitoring it, but we shouldn't report on it if it hasn't jumped to bigger platforms like Facebook or Reddit, for example. And then number 4 is, was it shared by an influencer or a verified account? Because what we've seen extensively with the coronavirus, for example, is that verified accounts and influencers share misinformation, and then it gets picked up very quickly by a lot of people. And then finally, of course, if the mainstream media has published disinformation, then it is the final sign that the misinformation has been amplified, has reached a wide readership, and therefore it is very important to cover the issue and analyzing it. So often when we teach about these things, we ask ourselves what the tipping point is, how many thousands of tweets count, what's the threshold, what are the exact numbers. And of course, this depends very much on the context of the audience and of what you are researching on. Of course, if you are in São Paulo or if you are in a small local newspaper in Ohio, it changes a lot what these metrics are. So let's go through Crowdtangle and trend data. So first of all, if you don't have access to Crowdtangle, you can request it through the following email address. It's free for journalists and researchers, so we recommend you to use it because it's one of the best tools that we have at the moment. As I said, it's not the best, it's not perfect, but unfortunately it is what we have to access Facebook data. So I will show you step by step how to get historical data. I recommend that you use the saved search function to download data because it is one of the best that allows you to tailor your research to specific keywords or phrases. So here we are on the Crowdtangle homepage. I'm sorry if some of you already know how Crowdtangle works, but I'm just gonna go step by step on how to download the data. So this is the specific dashboard for Facebook, but you can do the same operation on Instagram and Reddit. See here, there is the saved searches option, and you can click on new search and you can choose between pages and groups. Again, the Crowdtangle settings are a bit flimsy and inconsistent. So unfortunately, you can't search for both public groups and pages at once. So unfortunately, you have to do the same operation twice and then merge them together. So once you enter your search and you save it, you want to give the research a name. For example, this was a search that I was doing in the first months of the pandemic and right before the summer, when we have seen a lot of misinformation around coronavirus dying at a temperature of 26, 27 degrees Celsius. And in this example, we wanted to see how much traction these rumors have gotten. So I gave the name to these researchers as a generic high temperatures, wrote it down and then save it. So once you've done that, you have to go to the edit search feature and click on that. And that results in the following setups. So here we have Crowdtangle version of an advanced search with like Boolean searches. So the commas are the OR statements, and we can combine that with other keywords with AND, meaning that we get all the posts containing one of these words and the 2627. So coronavirus and 2627, coronavirus and 2627, or COVID 2627. So then you have to click on save, and you can add as many search queries as you want. Then you can also set filters. For example, the language can help us to restrict the search field. Then in the next step, we click on post, and here we can change the parameters that we are interested in investigating. Again, the beauty of Crowdtangle is that it gives us very rich historical data. So for the purpose of this example, we created a specific time frame, but you can go back even like a few years. And then we're also interested in the total interaction function. We want to see the total of interactions that each of these posts has gotten, which would be the sum of likes, comments, shares, etc. So at this point, we press go, and then we click on the icon on the right to download the data. And after a few minutes, it depends on like how many data you're requesting. After a few minutes, you will receive an email with a CSV file. Again, as I said before, unfortunately, you have to repeat the exact same steps than we did before, but with the groups, or you can just focus either on Facebook pages or on groups. And once you have downloaded them both, this is how the CSV will look like. And it's based on your search, of course. So there are a number of very interesting fields. For example, you can see the type of content. If it's a video, a link, you can see when it was created. You can get the post IDs. And then there are like these different types of interaction, which are very interesting because you can do different types of analysis depending on what you're interested in doing. So you can get the shares, you can get different reactions, emojis, and also the total. And below you can see like all the different fields that are available when downloading the data. All right, so once you have the two files, the next step is to merge them into one file. You can use whatever computing language or data analysis tool you're most familiar with. We mainly use Python and Pandas, so I'll show you this in the example, but you can do the same with R or even with like Excel or spreadsheet, even though it could be a bit more time consuming and there's quite a bit of cleaning required. So what we do here in the second window is first a function to read the CSV, and then we change some of the fields, like for example, the format of numbers and dates to make them Python readable and to perform mathematical operation or to analyze the trend over time, because most of the time they arrive in a string format. So we have to change them into numeric and date format in order to make them readable. So at this point, we can merge the two data sets. Anyway, this code is available on GitHub, and I will share the links at the end of these slides. Once the data is merged, we can start doing a bit of exploration with this. So on the first line, we see that these keywords with my filters produced 12,485 number of posts, suggesting that there are this number of misleading or not misleading public posts talking about the fact that at 26-27 degrees Celsius, coronavirus dies, which we know that it isn't true. So we're also interested in shares, which brings us back to the tipping point. Rather than likes or comments, like as we said before. So we sum up the shares and like we get a quite large number in this case, 681,000 times that this post has been shared on Facebook. We also want to see if they've spread more to groups or to pages, in this case, more groups. So a group is still one of the most prominent channels where misinformation is spreading. And this could be another interesting angle. We can do a little bit of statistical analysis that can give interesting results. Like in this case, for example, the average number of shares per post is almost 55, which means that each post is shared 55 times, which is like a pretty significant amount compared to what we generally see. So this tells us that this specific piece of content certainly produces some traction. Another analysis that we can do is the trend over time. Again, it's very important to talk about the tipping point and see how the number of shares resulting from this post increased. So we can see that it spiked in mid-March, So this tells us whether or not to publish something about this. So if it is going up, we might want to do an explainer or publish a debunk about it. But if we see, like in this case, if we were in April 2020 now, the trend of this content was going down to very low levels. And so maybe it would have been important for us to monitor it, but we shouldn't be publishing a report on it and amplifying it further. So another thing that we can do by playing with the data is to see which posts have had the most shares. In this way, we can reveal like some of the more important messages and we can analyze the content. But it also reveals the different pages and groups that share them the most. And something interesting can come out. For example, in this case, it's interesting that the number of pages in different languages are quite many. So when we look at this, we have like Russian pages, for example. We got a French page, a page that is arguably from Thailand, one in Spanish. So what we can see from this is that this content isn't restricted to one specific context, but it means that the rumor has become pretty global. We can also look at the pages and groups that post most frequently to analyze, for example, if there's any inauthentic activity or amplification networks that emerge with like pages coordinating in pushing their content. Or we can even just like simply analyze the pages that share the most and add them to the account list that we are monitoring. For example, we have this official sounding page, Coronavirus 19 Information and Sensibilization DZ, which I think is like kind of, funny name, especially one that's posting this kind of content like 12 times. We also have coronavirus updates, which also has been seen to publish quite suspicious and misleading content in the past. So this just gives us a nice little list of problematic pages that you can then just add to pre-existing lists that you're monitoring or just create new ones. Then we can also look at the most recurring links in the data set to, for example, images, photos, domains, any kind of like media content. Oftentimes, these reveals more than like the analysis on the messaging and the actors, like the medium that is most associated with. Like in this case, there were many photos of nurses and doctors, for example. So they appeared relatively official, although they were not. And what is interesting about like the specific post is that it came like prefaced with like messages like my friend from the CDC or UNICEF and the WHO said this and that. And with the pictures of doctors and nurses, people often don't scrutinize that much, as this is enough to like for convincing them of the reliability of the post. So this was just a very quick run through some of the basic actions that we can take with Crowdtangle's Facebook data. Obviously, the action that we need to take on the data are always shaped by the questions that we are querying it with. And they vary from like case to case. For example, you can download data from Instagram and Reddit, or we can also look at other things like accounts linking to specific URLs or YouTube videos, links to misleading articles, which is like an element that has proved particularly interesting in our research. We can also look at timestamps of posts to look for example, possible coordination, which is something like we can also do with the Crowdtangle API. The same link, like shared by a network of accounts in the same fraction of time, could reveal a coordination action, even though not conclusively. Or another thing that you could do, for example, is sorting the data by time and date of publication, which could tell us how and when the content was amplified and reveal a disinformation campaign. So again, there are many things that you can do. And even though the data is limited, Crowdtangle gives us access to different approaches and combinations of these that are like practically infinite. So let's look at some basic techniques for accessing the Twitter API. As I mentioned earlier, the API does not allow us to access historical data. There are a number of methods for like scraping all data, but it is a little bit more advanced in terms of coding. So for now, we'll just focus on scraping the data through the API, and specifically the search API, which allows us to get data based on hashtag keywords, like for up to a week. First of all, it's useful to see when you look at a tweet, what kind of data is out there. So everything on a tweet that we can get from the API, there's the account name, the Twitter handle, like all the information about the account. Then there's the text of the tweet with hashtag mentions and links, the content, so whether it is a photo or a video or a link, the timestamp and the engagement metrics, like with retweets, likes, and comments. And all of this, of course, translates into data. So I'm going to show you step by step some of the basic techniques for accessing the API that you can use to get like the most useful information for your research or your writing. So we're going to use a Python package called TweetPy that first of all you need to install on your computer. We can do this in two main ways. One is using pip install directly on the terminal, which for those of you who are unfamiliar with Python is a package for installing programs, or you can clone the GitHub folder on your terminal. And then we need to create a file that ends in .py, which is modeled after the code that I will share with you afterwards. In order to get the access to the Twitter API, you need to apply for developer credentials via the developer Twitter site, where you need to create an app and answer a series of questions. So when Twitter approves your application, you receive these tokens, these codes, which basically grant you access to the data. Generally, this only takes a few days. They have clamped down a bit just because of the amount of inauthentic activity they have seen on the platform over the last years, but you should be able to get it quite easily. So at this point, the code must be constructed. Again, for those unfamiliar with programming, we provide this file afterwards. So you'll just have to copy and paste the code into a text editor and then follow the instructions. Let's see how the code is structured, and then we can break it down into simple steps so you can then change it accordingly to your needs and on what you want to research. So the number one is where you enter your access tokens. The number two, the circle number two, is where we enter the specific search. It could be a word, a phrase, an hashtag. In this case, I was looking into the kind of debate around whether or not coronavirus is airborne. And I was looking to analyze what the conversation was on Twitter about this. So my query term was airborne. You can also input hashtags here. So if you want to collect a list of hashtags, or you can input, for example, a particular phrase to it. So there are many different ways of doing it. And then you want to put your date. So number three is the time range that we want to get. Most of the time, we want to get as much data as possible, which again, only comes back to a week time with the API. So we would always use that. Number four is how many tweets you want to get So we have this to 100K. You can do this like to 5 billion. It doesn't really matter. And yeah, don't alarm if the number of tweets is lower than the items that you have inputted, because that just means that there haven't been that many tweets related to that query. And then number 5 is all the information that we want to get from the API. And we can find the documentation on the website, on Twitter site. This is just an example of some of the categories that we can get. Yeah, that little snippet of code is essentially like communicating with Twitter, telling which data fields to retrieve, and then throwing them into a data frame. The data will then be exported in number 6, where you need to set the path to the folder where you want to save and the CSV file name that you want. This is how it looks as the CSV file that's outputted from this. So you can see the data fields that we asked for, like organized in different columns. Some data fields are empty just because they were unavailable on Twitter, like location settings, for example. So again, as we did with Crowdtangle, now it's time to clean up a bit the data and to analyze it. Again, I'm going to share all of these codes with you afterwards so you can replicate the analysis. So we're going to, first of all, open the CSV on Pandas. And in this first step, we upload the file and we identify some tweets that have been uploaded in the wrong format, and then we clean them up. After cleaning it, we can see how much data is there, which is 100K. So in this case, maybe I should have put a higher limit here because the number of posts was likely to be higher. But anyway, so we can now move to undo some analysis of what we have downloaded. Based on the questions, of course, that we have, like from a journalistic point of view, we will try to get certain data. And in this case, we are interested in the most frequent content with respect to the question. So what are the most frequent messages in the data set? Because we want to understand the conversation about whether or not coronavirus is airborne. So a look at this reveals that the WHO is the most retweeted text in the data frame, which is kind of optimistic and hopeful in terms of like, you know, like there is official good information that is dominating the discussion on this on Twitter. But if you go down, you see that there's a lot of conflicting claims around that as well. So there are many instances in which people say coronavirus could be airborne, and they use like a Fox News study, for example. So you can see how like convoluted and confused the discussion is on Twitter. And this little snippet of code will just reveal that. Then we also want to know when the accounts in our data sample were created. So the date of creation of an account, as we were saying before, could be a good sign of inauthenticity. If, for example, you get like a large number of very recent dates collected in a short period of time, which we do not see here. We can also analyze the hashtags that are most commonly associated with our keywords. And I found this very interesting in many of the work that I've done, because you can understand the narratives that revolve around this topic. So we need to create a function to basically extract these hashtags from the text. So you basically isolate the tweet text column, and then you build a function to extract those hashtags, and then we put them in a new column, and we analyze them by displaying them in a graph. So after we run this code, it reveals that the top 2 hashtags are unsurprisingly COVID-19 and coronavirus. But if you look further, you find some like interesting examples, like for example, Fox News, WW2, that's linked to Trump supporters, and you might want to then go and scrape tweets around those hashtags to see like what information is associated with them. So these were just few tiny examples of what you can do with the Twitter API. You can also, for example, extract URLs and analyze which websites this hashtag link to. Then we can like rank them if they are reliable or not. We can deem kind of like how polluted these conversations are in this way. We can get the hashtags like we did for the tweets, but we can also do that for the description of the users, which gives us like a clear idea of what kind of account it is, of like what kind of network. For example, during the UK election, they were doing this kind of similar analysis. We found that a large group of Boris Johnson supporters had like pro-Trump hashtags in their profile description, and that therefore there were many accounts linked to the Trump campaign as well. And another thing that you can do is to analyze the accounts that appear the most and use tools like Gephi or other network analysis tools to build the networks and to like build an aggregations that emerge from this. So just to give you like a very quick example of some stories that we did at First Draft, where like we use some of these tools. Like in this example, for example, we wanted to see what was behind the hashtag surrender bill that was trending in the UK about Brexit. So we looked at how many times per day accounts in the dataset were tweeting, because a high rate of activity is typically the first indicator of inauthenticity. So like, yeah, we extracted hashtags, mentions, links, and other politically divisive or hyper-partisan words within the account's description. And this could tell us a lot about the network that we were looking at. So these on the left were the hashtags scraped from the Twitter bios of the accounts posting like surrender bill. You can see like there's a high incidence of make American great again that was like higher than back Boris or like make Britain great again, as well as like reference to the QAnon narrative when QAnon wasn't even like such a big thing and like cross-border like now. So we decided to look deeper into this like cross-border overlapping narratives and to publish an investigation over it. In this case, we also looked at the creation dates of accounts that retweeted a Boris Johnson tweet regarding Brexit. So the retweets were produced by many accounts created in the previous month compared to when the tweet was published. So that was like highly suspicious. And then, yeah, as I was saying before, you can use Twitter and Facebook data to do like a bit of network analysis, which has become a very important tool for disinformation expert, because you can analyze and gain insight into like the hidden networks and communities that drive information, and of course, disinformation online. Again, I know this was like a lot of things in a quick run through, but you can download our code. This is my colleague Rory Smith's GitHub profile, and you can reproduce it on your laptop. These tools are very effective when we come across an example of misinformation and we want to know if something that's actually circulating or like if it's an isolated case. So we have some measures and metrics to know how far to push our analysis. The tipping point argument like is very fundamental. We also have a few guides on the First Draft website where you can follow this process step by step.